Hey, it's Riffy. Again, Skeletal System Part 1D. I'm sure you've really missed these invigorating, exciting, and just downright awesome video notes. But here we go. What we're going to do is we're going to discuss in this Skeletal System Part 1D what happens now that you have a nice grown skeleton. No more growing necessarily of bone. You might still be growing in terms of height, but what happens to your bones when you are grown and you need to maintain a nice, stable, working, strong skeletal system? And then what we'll actually get into is what happens when you become old, brittle, and that system starts to actually break down. So here's some things you need to pull out of this. You need to be able to describe and understand and describe how the bone remodeling system works and how that pertains to responses to stimulus. You also needed to be able to understand what happens to the skeletal system as you progress in age. So, without further wait, here we go. So you have what are called remodeling and homeostatic mechanisms that are involved in just the skeletal system. Remember, homeostasis is the maintaining of a stable working internal environment. In order to maintain that, you have to have certain mechanisms or things that occur, and the biggest one that occurs is going to be called remodeling. If you think about remodeling a kitchen, you already have the kitchen there. You're just taking what exists and you're making it new. Think about that same thing when you talk about the skeletal system and remodeling. You already have existing bone. You're just removing some of the stuff that's there and replacing it with new stuff. So in adults, you have osteocytes that are in lacunae. These are the ones that are just maintaining normal working environment. They're surrounded by the matrix, and they continually remove and replace calcium salts, maintaining the stability of your bone. But what also happens is you have two particular other kinds, not as numerous in your bone tissue, but you have osteoclasts and osteoblasts. Osteoblasts are the ones that build. Keep in mind the osteoblast has the letter B in it, so think about building bone, osteoblasts. And osteoclasts are the ones that destroy or dissolve bone tissue. Now, you might be thinking to yourself, well, why on earth would we need to build additional bone tissue, and why on earth would we need to dissolve additional bone tissue? That's what we're going to get into here in a second. So, what ends up happening is as you have osteons formed by the osteoblasts or the osteocytes in your compact bone, you actually have osteoclasts that come in and they destroy old ones. The reason being is think of it like a house itself and the frame of the house. If you built that house out of wood, over time, the wood of that house starts to deteriorate in quality. It starts to decompose. It starts to degrade. That destroys the integrity or the stability of the structure. Your bone is kind of the same way. The older osteons don't have the ability to maintain strength. So what happens is you have this remodeling system, and that remodeling system takes old and replaces it with new, and that's done through the activity of both osteoblasts and osteoclasts doing that together. So 18% of the protein and mineral that are in your bone are replaced yearly. So if you take your entire skeleton and we're divided into 18 different sections, one of those sections would actually be in its entirety replaced throughout the entire year. So remodeling actually varies from region to region and bone to bone. So some bones don't go through as extreme remodeling as others, but it also has to do with the amount of stimulus and stress that are put on those bones. So for example, like spongy epiphysis is replaced, remember epiphysis is at the very ends of bones, 2 to 3 times per year, which a lot of times the compact bone itself isn't replaced at all. What you see here is you see a diagram. And what this is, it kind of outlines what happens with the bone remodeling process. These cells that you have, let me bring that back up again. The cells that are represented right here, these 3 cells that look like they're part of a Pac-Man video game, those 3 cells there, what they represent are actually osteoclasts. Remember, osteoclasts are the ones that come in and dissolve bone. So what you have here, this area outlined in the bottom here, that kind of looks like these are osteons. What that is the actual bone matrix or tissue. So these osteoclasts come in, and if you notice they have like brushes, and what they do is they dissolve away some of the bone matrix. Maybe this is the older bone matrix or an old osteon or something along those lines. Once they've dissolved enough of that, and by dissolving it, they actually remove some of the calcium and phosphate minerals, and it gets put back into the bloodstream. Well, once they've done their job, you have these osteoclasts, they leave, And the osteoblasts come in. The osteoblasts are the bone building cells. Well, they take that calcium phosphate matrix, mix it with the collagen, which we talked about and did in our bone strength or density lab, put that all together, and what you end up with is, in fact, a newly formed bone tissue. That newly formed bone tissue is stronger than the old bone tissue that was dissolved. This is what remodeling is. Remember, keep in mind, remodeling the kitchen. You already have the kitchen. You're just taking away the old stuff and replacing it with new stuff. Hence bone remodeling. This is a real diagram of actual bone remodeling going on. And, for your level, it's not necessary that you actually have to understand what's going on here. So remodeling and support. So what happens is bone actually adapts to its needs, its stresses, and exercise. So that means the more stress, the more exercise, the more stimulus you place on bone, it actually will adapt to that and become stronger and stronger. The reverse can happen also. If you eliminate or remove stress from bone, you can actually decrease the strength, stability, and thickness of bones. So when you have what are called increased stress, now don't think of stress as a bad thing, think of stress as just another term for stimulus. But what happens is, let's say you decide you want to join a gym, and you start just not a muscle building program, but just a conditioning program for your muscles. And so you start lifting weights, you start doing bicep curls, you start doing squats, you start doing tricep curls, all these different exercises. Well, what actually happens is you have muscles that are attached to your bones. Well, every time you continually do those exercises, those muscles are continually pulling and stressing and stimulating the bone. What that does is it triggers a feedback loop to respond to that stimulus. It's saying that we are having an increased amount of stimulus or stress being applied to these bones. We need to make them stronger. In order to do that, they actually goes through the remodeling process. So your bone actually responds to the stimulus and stress by increasing the production of bone tissue. So in this particular instance, you would have an increase in osteoblast activity and not as much osteoclast activity. For example, let's say you were training for a marathon. A marathon is 26 kilometers, a little over 26 kilometers long, 26.2. That's a long way to run. So what happens is, as you run and you're training for that marathon over and over and over and over and over again, you're running, you're putting increased stimulus and stress on the bones of the feet, the bones of the legs, the tibia, the fibula, the femur, the joints of the knee. Well, that continued stimulus and stress increases bone activity, and you actually end up with thicker, heavier bones. Not longer, but thicker and heavier. So if you had Riffy pre-marathon and Riffy post-marathon, and you had the two people compared, you would see that I have a greater bone density after training for the marathon because of the amount of stimulus and stress. Now, again, like I said, the opposite occur. So decreased stress causes a decrease in bone mass. For example, let's say that you broke your hand and you're in a cast for 4 weeks. Well, the cast immobilizes your hand. It decreases stimulus or stress that can be put on the hand. Well, that decreased stimulus or stress, even though you're replacing the broken bone, doesn't provide stimulus or stress to the surrounding bone that is healthy. You actually end up with a decrease in bone mass. That leads us to our next entrance card. So the first entrance card here. Remember, keep in mind, I want you to write the actual question on one side and your answer on the back so you have a nice study resource. So here's your question. Why would you expect the bones of a weightlifter to be thicker and heavier than those of a person who had their leg in a cast while using crutches for 4 weeks? When you write your answer, make sure you use these terms in your answer. Make sure you use the terms bone remodeling, osteoblast, osteoclast, stimulus, or stress. And here's some motivational pictures. I don't know who this is, but this is a gentleman I went to high school with who is a professional bodybuilder. So let's talk about homeostasis now and mineral storage. If you remember correctly, one of the main functions of the skeletal system is storage. They store things like lipids within the bone marrow, but also they store minerals. Mineral storage, such as calcium and phosphorus, is not only essential to your bones, but other systems as well. For example, like your nervous system and your muscular system. Let's say you have, they highly depend on calcium, one for contraction of muscles, but the other, calcium in the nervous system, for the actual sending of signals to and from the central nervous system. Let's say you had an increase greater than 30% on calcium in your body, you would become unresponsive to your environment. Let's say there was a decrease greater than 35%, you would actually go into convulsions or seizures. So there's this fine balance of calcium in your body in order to maintain the ability to send signals to your muscles, but not only that, for your muscles actually have the ability to contract. If you have a 50% reduction in calcium within your body, you do in fact die. This probably has something to do with the fact that you can live X amount of time without eating, without absorbing any calcium, resulting in death. So let's talk about injury and repair in terms of homeostasis. One of the biggest things that can happen to your bone is you can break them. So all cracks or breaks in bones are called fractures. So you can have stress fractures, which are those little small cracks that usually occur in runners in their shins or tibia or fibula. And then you have hardcore fractures that can occur from car accidents. We're going to do a fractures project later on in this unit, but all fractures are classified based on their appearance, the site of the fracture, and the nature of the break, meaning the direction it broke and actually the method in which it was broken. As long as circulation still exists to the bone and the bone cells stay alive, the bone will heal. There are extreme cases of bone fractures where the bone tissue itself does not get a blood supply, or the bone cells itself start to die. What that causes the actual bone to die, and the only thing left to do there is amputation. But those are extreme cases. So keep in mind your bone tissue is alive and there are blood vessels circulating throughout. When you break a bone, as long as those blood vessels are still able to travel within the bone should be able to heal. So here's what actually happens in a fracture of a bone. So the bone tissue that includes the matrix and possibly down to the marrow, or can break all the way through. You can break all the way through and actually poke through the skin. There's varying things that can happen, but the blood vessels within the bone are broke and they bleed. What that then causes, it causes clotting. Just like when you cut your skin, it forms a clot inside of your body where the fracture occurred. That clot that forms with the fracture is actually called a hematoma. You'll see this term used in other places, but a hematoma is a clotted blood within the body. That fracture hematoma, what it does is it closes off the broken blood vessels so they have the ability to heal. And then you get a swelling reaction that occurs at the site of the fracture. That's why people that break their bones, their hands get swollen, or their feet get swollen, or their leg gets swollen. Not only is it swollen because of the reaction, but it's swollen because of the hematoma that's formed. Now, the cells of the periosteum and the endosteum, the two layers of the bone, the one on the outside and the one on the inside, they start dividing rapidly, forming really thick sections called calluses around the broken area. Think of calluses just like skin. When you have repeated use of your skin, you form those hard, dense calluses. Well, when your bone breaks, you form hard, dense calluses around the fracture. And what these calluses then do is they differentiate. Remember, differentiation is when cells change or become very specialized. Well, the cells of the periosteum and endosteum can differentiate back into chondrocytes. And if you remember back when we talked about the formation of bone, chondrocytes, almost all bone starts from cartilage. Well, what happens then is those chondrocytes start to build cartilage, and you get that bone formation process starting over again, just like when you were in the womb and just like when you were growing as a child. So the osteoblasts then take that cartilage and they start replacing it with spongy bone. So the process ends up starting all over again. You end up with the osteoblasts building that spongy bone. That spongy bone is then remodeled through osteoblasts and osteoclasts over time and forms that thick, compact bone outer structure around it, and it also forms that nice spongy bone inside section where the medullary cavity is, which that bone that forms in that fracture is just as good as the original, and at times it's actually thicker. So if you've ever had fractures or chips or anything like that in your bones, like soccer players with shins, if you run your hand down their shins, you actually notice that on that tibia, you'll see raised sections where probably chips or small fractures occur that you didn't even know, but they have healed through this process and actually become thicker or protrude a little bit further out than normal. So let's take a look at this picture here. So in week 1 where you had the fracture occur, you notice the blood vessels have broken, they've clotted, and they formed a hematoma. See this clotted blood around it, around that particular thing. Well, what then happens is that clot or hematoma, the periosteum and the endosteum, which is on the inside, remember they differentiate and they divide many times over and form a callus. Those callus cells then actually become osteoblasts, and what they do is they start building a spongy bone matrix, just like this, right in here. See how it is still a thickened section because of that hematoma. Well, then over time, the outer portions, through that remodeling process, which we've already gone over, forms the hard, dense, compact bone on the outside, and there's still some of that spongy bone left on the inside where the medullary cavity is located. Another diagram, you'll see it as right here. Normal functioning bone, boom. Bone breaks, blood vessels break, hematoma forms. You have this callus formed through the dividing of the periosteum and endosteum cells that turn into chondrocytes. The osteoblasts that exist take those chondrocytes and slowly form that cartilage into compact and spongy bone right in here. And then through time, the compact bone is remodeled until it's formed into regular compact bone and spongy bone, healed perfectly. It's a beautiful thing. Okay. Now let's talk about the effects of aging. You know there is a higher incidence of broken bones the older people get. So as you become older, your bones actually become thinner and weaker with age. Osteopenia is the natural occurrence or the decrease in bone density due to inadequate ossification. Basically, your remodeling process slows significantly to the point where you don't really respond to stimulus or stress anymore, and you actually have a decrease in bone density, and they become thin and weak. A lot of this has to do with the fact that in remodeling you have a balance between the activity of osteoblasts and osteoclasts. Well, in osteopenia, it's the regular decrease in osteoblast activity, and osteoclast activity remains a little higher than those osteoblasts. Women lose more bone mass than men, 8% a decade, whereas men lose about 3% a decade. Then there's a severe case called osteoporosis. Osteoporosis and osteopenia are related in the fact that they are both bone mass decrease reductions, but osteoporosis is severe. It's actually where you could have probably a significantly greater than 8% or 3% reduction in bone mass over time. And what happens is it greatly affects normal function to the point where they actually have to be relatively conscious of activities they do, because simple things such as walking could cause bones to break. This does affect men more than women due to a decreased amount in hormone levels after menopause, but you're going to have to get into that a little bit more specifics. But if you look at this, here's your normal bone matrix, and here's what happens when osteoporosis starts to form. So you can see how it becomes thinner and more brittle and less bone mass. Here's a nice picture of an old man that broke his hip. And here's the effects of osteoporosis over time. If you notice, the human beings get shorter. You can think of your grandma. Has she gotten shorter since you were born? And it brings us to our last entrance card. Answer the question below on an index card. Write the question on one side and the answer on the other. What's the difference between osteopenia and osteoporosis, and why do women experience higher rates of osteoporosis than men? What you need to do is, I didn't in the previous slides go into as much depth, but you need to look into hormone levels of older men and older women and how that could possibly affect a higher rate of osteoporosis in women. That's riffing. That's the end of part D, number one, part D. Let me know if you have any questions, as always.